Hello, Serial Wombat fans. It's John Broadwell of Broadwell Consulting Incorporated, medical device and embedded systems development consultant. If you need help with those things, give me a call. For the last couple of years, I've been promising you guys, oh yeah, a Python library is coming, a Python library is coming. And you may have noticed it's been a few weeks since I put out a substantive video. It's because I've been working. And I'm getting close to being able to release a Python library that is full parity with what's available on Arduino and C#. And to do this, I put quite a bit of work into this. The first thing I did was to refactor a lot of the C++ files that make up the Arduino library and turn those into purely .h files rather than having the headers in one place and the implementation in another, because virtually every other language that I want to deal with works that way. C# and Python both do. So I did that to begin with, changed a lot of things, went through and changed things like previously I was using a lot of triple slashes, and I went to block comments instead. That'll make the transition easier, and just a variety of things that make it easy for me to do a file by file comparison that actually make the C++ code and the C# code line up in a way where I can visually audit them to make sure that they're the same. Some of you may know I have an extensive library for unit testing that relies on this specialized board that you see here that uses Serial Wombat 4B chips interacting with the Serial Wombat 18AB chip and a few thousand lines of code that essentially goes through all of the different parts of the chip and tests the functionality of the Serial Wombat 18AB chip against signal generation and measurement from the Serial Wombat 4B chips. So I've been in the process of porting all of this code as well. So let's talk a little bit about what you can expect from the Python code. First, it's a direct port from the C code, and I'm trying to make it as literal a port as it possibly can for the reason that I showed before. I want to be able to do a file by file comparison, and especially like the file that we're looking at right now is one of the examples that goes with the Arduino library. I want the interfaces for Python, C#, and C++ to match as closely as I possibly can. And so in a lot of cases, that means doing things in some languages that isn't necessarily the way that you do them. Like, typically the Python code I've seen tends to use more underscores rather than camel case, but we're using camel case the same as in the C++. You'll see that there'll be places where I'll implement Arduino-based functions like delay in order to get that same functionality. In some cases, in the C++, I have macros that expand bytes into little endian format. There is an easy way to do that in Python, but I went ahead and kept these as functions so that they match up across the files. You won't notice a lot of this stuff. Most of what you'll see as a user is likely to be up on the surface, but if you take the lid off and look underneath, you may say, boy, this looks an awful lot like C++ code that was shoved into Python, and you'd be right if you said that. But there is a reason, and the reason is, number one, it makes my job a lot easier trying to maintain 3 separate languages, and secondly, it should make it pretty easy for somebody who, say, develops a robot in Arduino to show that same code to somebody who's developing a robot and wants to use a Raspberry Pi in Python, and be able to use all of the same Serial Wombat chip functions across both, with code that should be easily ported from one way to another. So, if you're a Python programmer and you watch one of my videos on how to use a pin mode and it's written in Arduino, you should be able to look at the examples, which will be ported from Arduino to Python, and be able to do almost exactly the same thing. So that's really what I'm going for here. So just so you know I'm not blowing steam, let's take a look at a quick example. If we go into the Arduino, we can go into examples, Serial Wombat 18AB, WS2412. And this is just an RGB LED example. The Serial Wombat can drive WS2812 LEDs. And this one implements a stoplight. And we saw this in a previous video where we introduced the WS2812 code. But I took this exact same example and ported it to Python using the same interfaces through the Python library. And we can see here that all of the same code exists, and therefore we can make the exact same function calls to a WS2812 object and do the exact same thing. And as you can see from the little video here, we get the exact same result if we're using Python to talk to the thing over UART as if we're using Arduino to talk to the thing over I2C. And that's the ultimate goal of this product, was to, really try to create a universal interface device perfect for embedded systems tasks that would work on a variety of platforms. And so, look for this probably middle to the end of November, early December. I'll be doing a release of the Python library in its first versions. Would certainly encourage any of you to look through it and give me some recommendations within the scope of what I've already told you, which is that, I want to keep it as harmonized with the other two languages as we possibly can. So that's all I have for today. As always, leave me a comment or suggestions down below. If you need help, go to help@serialwombat.com. And, by all means, please keep buying the products on Amazon and, and supporting the project, because, that's really what keeps it going. And again, you need help with an embedded systems project, hit me up at broadwell.consulting, and you can see what I can do for you from a consulting standpoint. So until we meet again, keep making stuff and have fun. The Serial Wombat firmware is available on GitHub and is constantly being updated. Subscribe below so that you can see the latest features and videos that come out as we fix bugs and add new features. The Serial Wombat open source project was created by Broadwell Consulting Incorporated. Broadwell Consulting Incorporated provides help developing medical devices with a focus on developing embedded firmware, which is compliant with IEC 62304, ISO 14971, and ISO 13485, as well as remediation assistance for products already in production. For more information, contact John at Broadwell Consulting. Support requests for Serial Wombat should be sent to help@serialwombat.com and will be answered on an as-available basis. Also, feel free to leave your question in the comments below.